Deciphering Extreme Weather Events in 2021. Insights from Attribution Studies. The 2021 report from the Intergovernmental Panel on Climate Change, or the IPCC, has brought a significant revelation to the forefront of climate science. It has underscored with increased confidence the profound influence of human-induced climate change on extreme weather events. This revelation goes beyond previous assessments and carries profound implications for the future of our planet. The central message of the IPCC AR6 report is clear. A warmer climate will magnify the intensity and frequency of both extremely wet and exceptionally dry weather conditions. This has far-reaching consequences for phenomena like flooding and droughts, and the impacts are expected to be felt globally. The report also highlights predictions with high confidence that the precise location and frequency of these extreme events will depend on regional atmospheric circulation patterns, including monsoons and mid-latitude storm tracks. Moreover, the report reaffirms and strengthens previous conclusions regarding temperature extremes. It states with high confidence that heat waves will become more intense and frequent in all continental regions, while cold extremes will decrease in intensity and frequency. These changes in temperature extremes are already apparent and pose significant challenges to ecosystems, to human health, and to our modern lifestyle. Beyond the IPCC report, other independent studies highlight the tangible effects of these climate shifts. Prolonged periods of extreme heat, rising numbers of drought events, and subsequent forest fires are becoming the new normal. This in turn has led to the extinction of certain species and has adversely affected vulnerable populations and caused health issues.
Okay, weather extreme events are impactful for populations, and they induce a lot of problems in terms of loss of human lives, agriculture, health, but also infrastructure. So knowing whether climate change affects their intensity and their frequency is a key question to adaptation and also for the scientific community. In fact, we have to know whether events with a changing climate will intensify, disappear, or even new events could appear. For example, we can imagine tropical cyclones hitting the Atlantic coast of France. We can imagine heat waves that have not produced before, hitting Arctic regions such as Greenland. And we see already that new events are appearing. For example, precipitation amounts that are falling in few days and that are expected to fall in few years. So all of these events, they need to be attributed to climate change. They need to be studied from the point of view of the changes in their frequency and their intensity. And the way we do this is there are different techniques. One is to look at whether the events could have been produced in a world without climate change and in a world with climate change. To construct these two worlds, we can use statistics. For example, if we have a long series of observation of rain in Greece, we can decide to study the two parts of the time series as the first one, the first period, the one that is less affected by climate change, and the recent period as the one that is affected by climate change, and study the difference, whether now it rains more or less, and investigate why. We can also construct the world with and without climate change using climate models, because in climate models, with the equation of the climate dynamics, we can set the greenhouse gases concentration to pre-industrial level or to the current level, and so run simulations that produce extreme events in the two worlds and study the difference between the events, also using statistical techniques.
The scientific literature also underscores the importance of understanding the dynamic drivers behind these extreme weather changes. For instance, in winter, increased persistence of cyclonic and anticyclonic weather systems can lead to extremely wet or dry periods, as observed in the eastern Mediterranean. During the northern hemisphere summers, changes in the persistence of synoptic systems are expected, further altering weather patterns and regimes. As we continue to grapple with global warming, researchers have highlighted the rain variability associated with both tropical and extratropical storms and convective events in the shoulder seasons. These shifts fundamentally alter the hydrological cycle and have consequences for agriculture, water resources, and ecosystems. In the quest to raise awareness about the consequences of greenhouse gas emissions, the scientific community has delved into the field of attribution. Attribution studies seek to connect single extreme events to climate change, providing a tangible link between our actions and the resulting weather extremes. By attributing specific events to climate change, we can better inform the public and stakeholders about the real-world impacts of our actions. Traditionally, extreme event attribution relies on statistical methods grounded in extreme value theory. While this approach can estimate return times of threshold exceedances for certain weather variables, it lacks consideration for the underlying physical processes driving these events and incorporates high uncertainty. Climate change is associated with complex atmospheric changes that are often overlooked by traditional attribution methods. Recognizing this limitation, efforts have been made to incorporate knowledge about atmospheric circulation patterns into attribution studies. This holistic approach acknowledges that atmospheric dynamics play a crucial role in understanding extreme weather events influenced by climate change. The IPCC AR6 report and subsequent research have brought to light the undeniable influence of anthropogenic climate change on extreme weather events. These revelations call for urgent action to mitigate our impact on the environment and adapt to the inevitable changes in our climate. Understanding the complex interplay of atmospheric dynamics and climate change is essential both for accurately attributing extreme weather events to their underlying causes and for making informed decisions to address this global challenge.
To do attribution studies in the area of the Mediterranean, we have to consider all the confounding variables, so the things that can compete with the CO2 and the other greenhouse gases emissions to change the statistics of the extreme events that we studied that we want to attribute to human-driven climate change. So what are the possible effects? We have the natural variability of the climate, such as the fact that the ocean has a certain phase. We know, for example, the phenomena of El Niño, La Niña, so the tropical ocean can be in warmer or colder states just because of the fluctuations, the natural fluctuations of the climate. This is true also for the Atlantic. In the Atlantic, we have other phenomena, such as the Atlantic multidecadal oscillation that makes the Atlantic warmer or cooler depending on the decades. And of course, also the Mediterranean has phases when it's warmer or cooler depending on the years. And we have to take into account this when we do attribution studies. Why? Because the human-driven climate change can add on top of these fluctuations and make the events worse or less impactful. For example, in this 2023, we have that the Atlantic Ocean is very warm, well beyond the average human-driven climate change, that is about 1.2, 1.3 degrees. We are, for the Mediterranean, are 3-4 degrees warming that project us already in a much warmer world and make us see extreme events that we are projecting on average for 2030, 2040 years. So it is important to distinguish these confounding variables that are linked to the natural variability of the climate and attribute only the part that is responsible for the greenhouse gases emissions to extreme events.
In an important paper published in 2022, scientists reported on their investigation of the impact of anthropogenic climate change on extreme weather events. They took a closer look at some notable weather extremes that occurred during the 2021 calendar year, seeking to attribute these events to climate change based on large-scale atmospheric drivers. First on their list was Winter Storm Philomena, which brought heavy snowfall and extreme cold to Spain in January. Next, they investigated the late winter cold spell that hit France in April 2021, causing significant damage to vegetation and agriculture. They then turned their attention to the devastating July floods in Westphalia, Germany, which resulted in the destruction of entire villages, massive infrastructure damage, and the tragic loss of lives. Next, they examined the record-breaking temperatures during the August Mediterranean heat wave, which sparked wildfires in Greece and Italy. They also delved into the September Po Valley tornado outbreak, Hurricane Ida's extensive damage in Louisiana and New York City, and Mediterranean Hurricane or Medicane Apollo, which caused heavy flooding in Sicily in October. Finally, they investigated the November Scandinavian cold spell, which brought record low temperatures for the season.
We have developed a new website that is not just a website, in fact is a platform for studying the extreme events and putting them in a climate context. I wouldn't say that we do exactly attribution, because as we have explained before, to attribute an event to climate change, we really have to separate the world with CO2 emissions from the world without CO2 emissions, and we need climate models to do that and support this with the observation. In the ClimaMeter, this is the name of the tool that we have developed, and I invite you to visit www.climameter.org. We can put these weather extreme events in a climate context just by using the observation. So what we do is that we take an extreme event that is produced somewhere. For example, we have just analyzed the Medicane Daniel, that is a Mediterranean cyclones that hit Libya in September 2023. And we have looked at all the cyclones that looks like this Medicane from 1979 to 2000, and then from 2001 to present. So we have 2 periods, and we look for storms that are similar to Daniel in the 2 periods, and then we try to compare whether the storm in the present time produce more precipitation, stronger wind, and are associated with higher temperature than the past. This is indeed the case. So we find that cyclones are more impactful in the present time, and then we have to see whether the confounding variables that we have explained before have played a role in enhancing this phenomenon, or whether we can link this to human-driven climate change. So this is the analysis that we put on the ClimaMeter website. Our aim is to have a fast tool that can give a first answer whether the event has been enhanced by human-driven climate change in matters of hours after the event. But this first analysis that we do to put the extreme events in a climate context is not an attribution full study. It's something that motivates the attribution studies that have to be done by the scientific community afterwards, but is a tool to communicate extreme events with the media, with the scientific community, and to do a first analysis that put the events in a larger climate context.
To attribute these events to climate change, they studied the associated atmospheric circulation patterns, searching for recurrent patterns that they refer to as analogs. They compared patterns from the recent past, between 1992 and 2021, with those further in the past, between 1950 and 1979, operating on the assumption that the far past would serve as a counterfactual world when anthropogenic influences on climate were less profound. Their approach involved a 30-year time frame to average out high-frequency interannual variability in atmospheric motions. However, they acknowledged the need to account for lower frequency and interdecadal variability, such as the Atlantic Multidecadal Oscillation or El Niño Southern Oscillation, to ensure a robust analysis. If changes in analogs between these 2 periods could be attributed to climate change, it would provide valuable insights into the evolving impact of the anthropogenic effect on extreme weather events. Unlocking the secrets of extreme weather events in 2021. A closer look. In the dynamic world of climate science, understanding extreme weather events is a puzzle that scientists are working tirelessly to solve. In 2021, a series of high-impact extreme events commanded our attention. What if we told you that scientists have been diligently analyzing these events from a new perspective? Seeing through the veil of attribution. Researchers delved deep into the atmospheric circulation patterns associated with these extreme events. Their approach was rooted in attribution, a method that aims to discern the fingerprints of human-induced climate change. To paint a clear picture, they selected key circulation patterns for each event and traced their evolution over time. Journey into the past and present. To understand how these events might have played out in a different world, scientists identified analogs from 2 distinct periods. The 1950 to 1979 era, representing a counterfactual world, and the 1992 to 2021 period, mirroring our factual world. Regardless of the uniqueness of each event, one striking revelation emerged: the profound influence of anthropogenic climate change on shaping the characteristics of these events. This insight holds immense significance for the broader field of extreme event attribution, the power of persistence and predictability. This study introduced 2 key players to the attribution framework: persistence and predictability. Persistence in particular garnered significant attention. Scientists have long debated how changes in atmospheric persistence might impact extreme events. This inclusion adds an exciting dimension to the analysis: a quality check on analogs. In their quest for answers, researchers assessed the quality of analogs in relation to atmospheric variability. This led to a third critical discovery: the ability to gauge whether a particular circulation pattern and its analogs are becoming more or less typical over time. Surprisingly, the quality of analogs for a given extreme event may remain stable, while the analogs of those analogs improve. This complexity highlights how extreme weather configurations relate to the broader atmospheric variability within a specific climate. The elusive black swan, Medicane Apollo. One event, Medicane Apollo, stood out as a black swan among Europe's weather patterns. The lack of suitable analogs underscored its unprecedented nature, making any attribution statements a daunting task. This revelation serves as a stark reminder that not all extreme weather events fit neatly into the historical sample. The road ahead, acknowledging limitations. Despite these exciting findings, the researchers acknowledge certain limitations in their framework. Factors such as the choice of the region for defining analogs, the time scale for selection, and the number of analogs retained for analysis introduce some subjectivity. Additionally, for only two events, the Po Valley tornado outbreak and Medicane Apollo, could natural interdecadal variability be statistically excluded as a contributing factor? A window into the future. While the study's main focus was on sea level pressure analogs, the possibilities for expanding this research to study long-lasting extreme events like droughts are tantalizing. The use of daily means, although limiting for some purposes, retains vital information about pattern persistence. Striking the right balance. The researchers found that working with 25 to 50 analogs struck a balance between meaningful statistics and selecting high-quality analogs. Similar hurdles in extreme weather attribution. It's essential to recognize that conventional extreme value attribution shares many of these limitations. The choice of region, thresholds, and timescales all present challenges in the quest to unravel the mysteries of extreme weather. This research not only sheds light on the past, but also guides our understanding of future extreme events in a changing climate. The puzzle may be complex, but scientists are piecing it together one circulation pattern at a time, inching closer to unraveling the intricate tapestry of extreme weather events.
Extreme events can be very impactful for the health, for agriculture, for the energy production, for transportation system. So we have seen that many extreme events that hit Europe and the Mediterranean areas cause different impacts depending on the vulnerability of the territory where they actually happen. One example is that with the precipitations that we recorded in Libya yesterday and the day before yesterday, I'm talking about the 12th and the 11th September 2023, we had about 400 millimeters of rain in a few hours. This is an enormous amount of rain, and this caused several thousands of casualties. With the same amount of rain in Sicily, but also in Liguria, in previous event, we had damages, we had life loss, but we didn't reach this enormous number of casualties. Why? Because with the experience that we have already from previous attribution studies in regions of the world that are more developed from an economical point of view, and that even have the money to invest in infrastructure that are more resilient to extreme events, we can reduce the damage of these events. For example, now in Liguria, in south of France, in Greece, amounts of rain such as the one that have destroyed the entire city in Libya can be handled. So the good news is that with these attribution studies, we can say to populations that are in countries that are less developed from a point of view of the infrastructure, but have the will to adapt for climate change. It is possible to avoid this disaster. It is possible to adapt the infrastructure. So the fact that these studies must come at the right time immediately after the event, and this is also one of the goals of Climameter, is important to make immediately the link between the event, the climate change, the exceptionality or not of the event, and how we can be prepared. So there are good and bad examples in developed or underdeveloped countries. One other example is the cyclones that strike Florida. We had a tropical cyclones in 2022 that was very destructive, even in a very high developed region of the world, Florida, United States of America. And also there are actions that could be taken to avoid this happening to the future. So it's not just a matter of gross product or developed or undeveloped country, is how much we have coordination between climate scientists, engineers, and how we handle this in the political world. And all this chain is important, and attribution and fast attribution is important to make immediately the link between the climate, so the physics, and the society.